Now there are cases where formulas can be used in the process of verifying identities. So for instance, in this example, we're going to verify that the cosine of pi over 2 minus u is equal to sine of u as an identity. So let's go through the process like we did in the last section. We'll consider both sides separate. The right-hand side is sine of u, and the left-hand side is cosine of pi over 2 minus u. Now since the sine of u is just that, we're not really going to spend much time looking at that side. We're going to focus on how are we going to try to make this thing look like the right-hand side. What we can do here is consider this like the subtraction formula for cosine. That was the cosine of s minus t is equal to cosine s, cosine t, plus sine s, sine t. So this could be like our s and our t. And so when we rewrite it using the subtraction formula, it would go cosine pi over 2 times cosine u plus sine pi over 2 sine of u. And we know the sine and cosine for pi over 2. For cosine, it's equal to 0. For sine, it's equal to 1. So since we see this as a 0 times cosine u, that's going to go away, and all that we're going to be left with is sine of u. So that right away confirms to us that the left-hand side is indeed the same as the right-hand side. So here's another identity to take a look at. Let's take a look at the right-hand side and the left-hand side. Now I'm going to do something a little bit different than I did in the last section. In the last section I mentioned how we would change everything into sines and cosines to get started. But one of the things we can do to kind of take a shortcut around having to do that is if we see a formula that we could leverage here, we'll go ahead and try to use the formula before we try to go into converting into sines and cosines. So if one of these things is a formula for tangent, then let's go ahead and use that first. Indeed we can, because this tangent of pi over 4 plus x can be worked with the addition formula. The addition formula for tangent went tangent s plus t is equal to tan s plus tan t divided by 1 minus tan s tan t. So that's what we're going to use here with s and t. We're going to put this as tan pi over 4 plus tan x all over 1 minus tan pi over 4 tan x. And we know what tan pi over 4 is. That's equal to 1. So make that 1 plus tangent x divided by 1 minus 1 times tangent x. And I just put the 1 times here so that you can see what happened to the tan pi over 4. It changed into 1. But we really don't even need to write the 1 times there. It's just 1 minus tan x, which is indeed equal to the right-hand side. So here's another example that goes cosine x plus y plus cosine x minus y equals 2 cosine x cosine y. So let's see how we're going to make this work. In the case of the right-hand side, it's 2 cosine x cosine y, so there's not a whole lot to do here, so we'll go ahead and leave this side as is for now and take a look at the left-hand side. What can we do to try to make this side change to look like the other side? Well, we both have both of these have trig formulas involved. Basically, one has the addition formula and one has the subtraction formula. So we're going to use both of those for cosine. If I apply those formulas here, the first one would go cosine x cosine y minus sine x sine y. And then if I use the other formula for the subtraction, it goes cosine x cosine y plus sine x sine y. So now at this point, we see if anything can cancel or go away. In this case, notice how there's a minus sine x sine y and a plus sine x sine y. Those will both cancel each other out. Okay, and then we have one of these cosine x cosine y's and another of those cosine x cosine y's, making us have two cosine x cosine y. And so now that's identically what we were looking for to make it into the right hand side.